Okay, so another smartphone counting question here. We have a newer smartphone by the looks of things, and it's a more secure smartphone because, as you can see here now, we have 1, 2, 3, 4, 5, 6 possible digits in our PIN. So the first things first is how many 6-digit PINs are possible. And notice it doesn't say anything about repetition, at least in part A. So usually how it works with counting problems, if somebody forgets to or doesn't bother mentioning anything about repetition, that it's usually common to assume repetition's possible or acceptable. So that would leave us with 6 spaces regardless. 1, 2, 3, 4, 5, 6. And using our fundamental counting principle, the number of choices for each digit would be 1 through 9 and also 0. That would be 10, followed by 10. Yes, 10 every single time. And that's assuming repetition is okay. And of course, remember our fundamental counting principle tells us that we need to multiply all those different choices together to predict the total number of branches that would be in this tree diagram. Notice that that's 10 over and over again, a total of 6 times. So that's going to be, I guess, 1 with 6 zeros on it. Or what most people would say, 1 million. So there's 1 million possible pins if repetition is allowed. And I got rid of my whole box there, unfortunately. There. Okay, so part B, how many 6-digit pins are possible if repetition is not allowed? And notice, it's not like we have to radically change our approach here. We're still going to go 6 spaces corresponding to the 6 digits in this pin. Only difference is, of course, we're going to start counting down. We could use any of those 10 numbers on our keypad there. And let's just assume if 9 was used for the first one, we can't reuse that 9. If 5 was used for the second digit, we can't reuse it, etc. And we don't see the same number like 10 occurring every single time. We see a countdown. 10, 9, 8, 7, 6, 5. Okay, of course that corresponds to 6 different digits. 10 choices followed by 9 choices, 8, 7, 6, and 5, and we multiply all those choices together following our fundamental counting principle. And we'll definitely use a calculator for this one. That was from the last question, I believe. So we'll go 10 times 9 times 8 times 7, 6, and 5. And that's going to be a big number. Of course, I would expect it to be smaller than the million that we have, and of course it is. It's 151,200. The wrong color there. 151, 200. And again, that's where repetition's not allowed. And if you see somebody's work, who is, of course, working with the fundamental counting principle, that countdown is a feature where repetition's not allowed, and the repeated number, in this case 6 times, of course, is indication that repetition was probably allowed. Okay, and make sure I copy that number down correctly, and I did. Part C, how long would it take you to try every pin in part B, just to show you how secure this smartphone is, assuming that somebody didn't just use 1, 2, 3, 4, 5, 6 or something kind of stupid like that, which unfortunately is pretty common with pins, but we won't assume that. We'll assume that somebody used a random number generator and got a 6-digit pin that was completely random and not based on birthdays or nicknames or anything like that. So how long would it take us to crack this phone trying every single pin? Well, an absolute eternity. So let's make one assumption, which is probably a pretty idealistic. Let's say it's only taken us 1 second to try 1 pin. And of course, it's probably going to take a lot longer than that. But if that would, obviously 1 second per pin, well, that would mean that's going to take us 151,200 seconds. So that's going to be how many minutes? It's going to be 2,520 minutes. And if we divide that by 60 again, that's going to tell us that's 42 hours. So if we divide that by 60 twice, as I just showed you on your calculator there, I guess if this was a test question, you divide that by 60 times 60, brackets on that, and that would correspond to 42 hours, which of course nobody in the right mind is going to do, and that's based on a pretty idealistic 1 second per pin. I'm sure it's going to take you a lot longer than 1 second to type in a 6-digit pin, never mind trying to keep track of all the pins that you're entering. So there it is. With repetition, we have 1 million possible 6-digit pins, and without, we're all the way down to 151,200.